Okay, free response question numero dos. We have ourselves calculator stuff, and as you can see from here, and if you're looking ahead, you're going to be like, yeah, I'm going to need a calculator for this one. You are. Let R be the region bounded by the first quadrant. So let's kind of draw ourselves a picture because I know what's going to happen, especially since I created this problem. The curves f of x, also the first quadrant, the curves f of x equals 1 over 21, x squared plus 1, and g of x equals e to the 6 minus x minus 1, and the x-axis. I don't know why and the x-axis has to be thrown in there if it's the first quadrant. Thank you, but no thank you, ChatGPT. Now, f of x is going to be this little parabola, this very wide parabola, and what we will see when we throw this into the calculator, f of x is going to look like this, give or take. Perfect? No. Accurate enough to get by? Mm-hmm. And what we will find about e to the 6 minus x minus 1 is it's going to look something like this. Okay? Again, perfect? No. Accurate enough? Yeah. So A is asking us to find the area of region R, of course, being the combination of these two guys, this shaded region, if I were to shade that black, which I will not do. All right, so what we need to do is we need to find the area of region R, and we're going to show all of our work. There's two things that I have to do before I throw this into my calculator, and I'm going to write it all out. Okay, I'm going to write it all out. What I want to do is the area under the curve is found by taking the integral, right? So if I were given just one function, if I were told everything happens between 0 and 8, I would take the integral between 0 and 8. Easy peasy. But it's not that easy peasy because I have two curves that run into each other. Okay, so issue number one is if I wanted to find this area, I'm splitting this into two parts. And this is how I'm going to handle all three of these problems. The intersection of the blue and the red here, I'm going to call A for now. Okay, for now. Now, what's going to happen here is if I wanted to find just the area under this blue curve, I would take the integral from 0 to whatever that A is, and that blue curve is f of x dx. That gives me this information right here, that area. Now, that's not all I want because I also need this chunk right here. That's going to be the integral from A to this guy, which we will call B. Now, everything is being held in the first quadrant, which means the moment it crosses the x-axis is when I'm done. Okay, B is going to be found by finding the 0 of g of x. So once I find A, which will be found by, intersections, and once I find B, that gets me this chunk right here when I integrate it. If I add this chunk and that chunk, I get all of R, and that gets me the answer to A. So what I'm going to do is I'm going to run to my calculator. I need to find A, I need to find B. Once I find those, I'm going to integrate them in my calculator, and I'm going to add those guys up and see what happens. So we're going to do all of this all at once. All right, so let's plug in both of those formulas. I'm going to let f of x be y sub 1, and that was 1 over 21, which I'm going to put in parentheses because I'm paranoid. Okay, x squared, and then plus 1. Okay. Y sub 2 is going to be my g of x. That was e to the x, so second ln, e to the 6 minus x. So let's throw all of that in there, 6 minus x, and then go out of here. And let's minus 1 because that was the other part of it. All right. Let's see what this graph looks like. Okay, so there's the picture that I drew, but a little bit flatter, maybe, I guess. So my thing, number one, is I need to find out what that A was. Okay, what that A was. Now, I do that by finding the intersection of the blue and the red. So I'm going to hit second, calc, intersect. So hit 5. Let's move closer to the intersections. For the first curve, I like to always hang to just to the left of it. Hit enter. For the second curve, just to the right of the intersection, hit enter. Always guess, hit enter again. And we are going to pocket the fact that our intersection is going to be 4.861. We're going to use that number over and over and over again. Okay? So A is 4.861. I still have to find B. Okay, now B is going to be the 0 of the red line. If I want to focus on just one of the lines, what I'm going to do is I'm going to go to y sub 1 and go to the equal sign and hit enter, so that all I see is the red line. So I'm going to find the 0 of the red line here by going to second, trace to calc, 0. Okay, so let's move to the right a bunch of times so I can see my little cursor. Come on, 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 there you are. Let's go to the left of the 0, hit enter. Let's go to the right of the 0, hit enter, and hit enter. And just like that, the 0 is 6. So my two key numbers are going to be 4.861 and 6. So now using that A as 4.861 and that 6 as B, we can do what we set out to do. So y sub 1 is going to be my f of x. Let's focus on that, and so we'll highlight the equal sign for just that. Okay, so let's graph so we can see just the blue line. Hooray, hooray, hooray. Now if I want to integrate this between 0 and 4.861, I'm going to hit second, trace, which takes me to calc, and there's my integral function. So, lower limit is 0, hit enter. Upper limit is 4.861, hit enter, and it fills it in for you. And what we get is 6.684. Okay, so we're going to write that out. We're going to, when we go back to the main slide area, we'll write all of this stuff out. But this is how you find the first chunk, the blue chunk. Now to find the red chunk, we're going to go back to y equals, pretend that blue doesn't exist by hitting enter on the equal sign, and by hitting enter on the equal sign for red, now we only see red. So if we hit graph, there you have it. We care about the integral between 4.861 and 6, so we're going to do the same exact thing with our new limits. Second, calc, 7, 4.861, enter, to 6, enter, and we get 0.985 when rounded. So we're going to take those two numbers that we just got, 6.684 and 0.985, and we're going to add those guys together, and that's going to give us what we need. All right, so we ended up with two pretty important numbers, okay? That A ended up being 4.861. That B ended up being 6. So rewriting this guy out was 0 to 4.861 f of x dx plus 4.861 to 6 of g of x dx. Okay, this guy gave us 6.684 plus this guy gave us 0.985. And dummy me, I forgot to show this part in the video. I don't know why I did that, but when you add these guys together, I think you don't need my help on how to add things in a TI-84 Plus. If you could do all of this stuff in a TI-84 Plus, I think you're good. So dumb move by me, but you get the idea. That's what we're going to get here if we were going to go back to our TI-84 Plus and add those up. So that's part A. Part A, dunzo funzo. Now, B is asking us to find the volume of the solid formed when the region R is rotated around the x-axis. So you spin this around, you're going to get some weird looking, I don't know, like the top of a hat thing. I can't draw these, so I'm not even going to try. But what we're going to do is we're going to use the same idea. Generally speaking, when you want to rotate a line around the x-axis to make a solid, the general formula for that is basically you take, and this is any line, so I'm not going to use F and G, I'll use R. So you would do pi times R of x dx, and you're going to use your limits. Now what I'm going to do is I'm going to set this up the same exact way, using these two guys being added to each other, but what I'm going to do is I'm going to square the functions. I forgot to say that over here. Square the functions and attach pi to it. Okay, so I'm going to write out from 0 to what I know now is 4.861. I'm going to put pi in front of it. I'm going to put f of x squared dx. And then I'm going to add from 4.861 to 6 pi g of x squared dx. So I'm going to run back to my calculator. I'm going to do all that fun stuff, and I'm going to see what happens. All right, so unfortunately going back and forth and doing all this stuff makes everything go away in my calculator, but no big deal. According to what I wrote out, let's do this. Let's make believe that I already have this stuff written there. So the original functions were, I believe I had it as 1 in parentheses, 1 divided by 21, and then you have x squared plus 1, and then the other one was e to the 6 minus x, right? Yeah. And then minus 1. Okay, so the reason why I'm rewriting it out like its original form is I want to show you how we can manipulate it so that it's not so bad and I don't have to clear everything and rewrite everything. So if I wanted to make these pi functions squared, I'm going to go to second, insert. I'm going to hit pi. So here's my pi. No. Didn't I do that? Second, insert. Hold on, let me go back. Let me delete it. I must have done something stupid. Second, delete, which makes me insert. I'm going to hit oh, I know what I did. Second arrow, which is pi, and I'm going to add another parentheses there. I'm going to go all the way over here and close the parentheses and then make that squared. Okay, so now it's exactly what I want it to be. So without me making any typos, let's try that again. Second, insert, second, caret, puts the pi there, parentheses, go all the way to the right, close it, square it. And now I'm going to do exactly what I just did before. Okay, so let's hit the graph, see what they both look like on the same thing. All right, it's definitely new, but that's okay. It's supposed to be. Let's focus on f of x first by eliminating, or not eliminating, but just, silencing the red. So now if I hit graph, I only see that. And we're going to integrate between 0 and that 4.861 number. So second, calc, integral, which is 7, lower limit is 0, upper limit is 4.861. And with that, we end up getting the number 38.594. So let's hold on to that, 48.594. The second one, let's go to y equals. Let's highlight u so I don't see you anymore. Let's highlight u so I do see you now. Let's hit graph to make sure there she is. Let's integrate that by hitting second, trace, which takes me to calc. Go to 7. I care about all the stuff between that 4.861 and 6. And it gives me a value there of 3.9907, which is 3.991. Now, what I forgot to do last time is let's add those guys up. Okay, 38.594 plus 3.991, 3.991, enter, and you get 42.585. All right, so let's go back and write that out. Okay, so you ended up being that 38.594. You ended up being 3.991. We added them together and got 42.585. All right, so that is how you do B. Now, C is extremely similar to B. C is saying instead of rotating it around the x-axis, rotate it around the line y equals -2, which is this line way down here. This requires the washer method. And generally speaking, what you do with the washer method is you would integrate, right? And I'll write it down here. You would integrate from A to B. You would still do whatever function that you have, right? You would still have pi out there. But then what you would do is you would take whatever your curve is, minus whatever number, okay, whatever number that y equals is, and then square it dx. So what that's going to look like here, is I'm going to have an integral from 0 to 4.861 of pi f of x minus -2 or plus 2 dx. Okay, and I'm going to add that to the integral from 4.861 to 6 of pi g of x minus -2 or plus 2 dx. Squared, squared. You can't forget to square those parentheses. That changes everything. Okay, so let's run to our calculator, see what happens. Okay, so coming back here and going back to the y equals that we had before, when we manipulated them, we're adding 2 inside each of the parentheses. So I'm not going to write out +1 plus 2 because that's a waste of time. Let's just make u plus 3. And instead of down here doing the same thing and writing out -1 plus 2, let's just make that +1 because -1 plus 2 is +1. So let's focus on just the blue. We're going to do the same exact steps that we did before. Focus on just the blue. Second trace takes us to calc. 7 is going to take us to our integral. I don't see anything, but who cares? I don't need to see anything. If I'm adding 2 squared, which is +4, it just moves everything up. So I'm going to plus, or my lower limit is 0. My upper limit is that same 4.861. If that number isn't burned in your memory after watching these videos, shame on you. We end up by doing that getting 175.675. Okay, so that's the first guy. The second guy, let's go back here. Let's hit enter so I don't see it anymore. Let's hit enter so I do see u. There u is. And let's do the same thing. Second trace 7. I care about 4.861 to 6. That value is going to be 30.677. Now let's add those two numbers up. Okay, 175.674 plus 675. Why did I say 4? Plus 30.677. And we get 206.352. Let's go back and circle that. Doo-doo-doot, says the computer. Let's go back, circle that, and be done. Thank God. All right, so this top guy ended up being 175.675. This guy ended up being 30.677. And when we added them together, we got 206.352. Yum, 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 yummy, yum, yum. I don't need that over there. That's in the way. All right, that was intense. So hopefully you enjoyed it because I certainly did. All right, more to come.